Good morning, STEM World! We need to go over some of these questions from that assessment you did yesterday. I went through and I highlighted on my sheet here and put little stars next to the ones that had the most missed. Not that it was the worst, but that way I don't have to go over every single problem. I'm just going to hit the highlights. All right, so number 2 was one of those most missed problems. Let's check it out. Okay, so what can we conclude? There's a 95% probability. No, that is not what confidence intervals do. It is not a probability. 95% of values sampled are between 6 and 12. You want to be careful. We want these to infer about the population. Right? This whole idea of trying to capture the truth so that we can make an inference about a population. We don't really want to talk about the sample here. If we took many additional random samples and from each computed a 95% confidence interval for mu, that would be the true value, approximately 95% of these intervals would contain mu. All right, so that one sounds really good. D is off the table because, again, it talks about probability. All right, the next most missed was number 6. All righty, so let's see. Let me go backwards. Which of these sources is included in the plus or minus 2% margin of error announced for the poll? Okay. Some people refuse to answer questions. That's non-response bias. People without telephones cannot be in the sample. That's under coverage. Some people never answered the phone in several calls. Again, non-response again. And when it comes to margin of error does not touch anything with these non-sampling errors and under coverage sampling error. The only thing margin of error takes care of is that natural variation. All right, natural variation that happens between samples. When you sample on Monday or sample on Tuesday or Wednesday, your samples are going to have that natural fluctuations. They're not going to be the same every day. So this margin of error takes care of that natural variation. It does not account for non-response and under coverage. There's not really a way to put a number on that. All right, there's just not. So none of these are sources of error for margin of error. All right. So then this side, everything looked good. Number 7. Alrighty, let me work backwards. Which of the following assumptions for inference about a proportion using a confidence interval has been violated? Okay. So we've got a radio talk show host with a large audience. He poses the following question to his listeners. Do you think the drinking age should be reduced? And he asks listeners to phone in. All right, so there's the problem. They are phoning in and voting, so this is voluntary response. If they're voluntarily giving their information, that is not a simple random sample. And random is that very first condition, right? We have to have a simple random sample or stratified random sample or even a cluster, all right? But voluntary, convenience, those are no good, all right? So we cannot do inference if they took a sample like that. All right, what is next? Number 17. A researcher plans to conduct a test of hypotheses, alpha level 01, for your significance. All right, that's your cut score. She designs her study to have a power of 0.92. The probability that the researcher will commit a type 2 error. All right. So when we get into type 1 and type 2 errors, the way I keep it straight is by memorizing this chart. I call it the Hot-Hoff chart. Hot-Hoff. Hot-Hoff? Hot-Hoff. All right, so when you look at that Hot-Hoff chart, you've got 2 options when you're running these tests, right? These hypothesis tests. You either reject the null hypothesis, or we fail to reject the null hypothesis. All right, so if the null hypothesis is true and you reject it, whoops, type 1 error. Null hypothesis is false and you reject it. Good for you. Null hypothesis is true and you fail to reject it. Good job. If the null hypothesis is false, it's a lie, but we don't catch it. We don't reject it. That's a type 2 error. So there's your type 1 and type 2 error. When it comes to the probabilities, the probability of a type 1 error is the same as your alpha level. All right, so whatever the alpha is. So right here, that's the probability of a type 1 error. All right, they want the probability of type 2 error though. That's down here. That's directly related to the power of the test. All right, the power of the test is this block. So type 2 is going to be a complement to it. All right, they're complementary. So if the power is 0.92, then the type 2 error is 1 minus the power, the complement. So 0.08 was your answer on that one. So when it comes to probability of errors, you just have to memorize the Hot-Hoff chart and work your way through. All right, what is next? Number 19. All right, we're doing a confidence interval, and they want to know which one of these substituted it in correctly. Let's grab it. Looks like they turned these into decimals, so I need to backtrack a little bit here. We had 125 workers from Company A. So Company A, 17, oh wait, no, 35 people, sorry. I hate when I do the words. 35 people out of 125. There you go. 17 employees from a random sample of 68 from Company B. All right, so let me turn those into decimals real quick. We've got 35 divided by 125, which is 0.28. T.I. Joe, looks like your battery is low. Oh no, I can't stop the rhyme. I feel so fine. 0.25. Okay. So, what else am I going to need? I'm going to need the critical value. So, for 95%, if you go and you look at the chart, the t-distribution chart, the z-stars are at the very bottom. So, 95% confidence uses 1.96 for the z-star. All right, so I'm looking for something with a 1.96. All right, so let me zoom in over here and see what we got. So I can get rid of that one, and that one's missing a z-star, so boom, boom, boom. All right, this 0.03, where is that coming from? Ah, yeah, it's the difference between these two groups, so that's good. So now I just got to check what's underneath the standard deviation symbol. We have the 0.28 times the complement over the sample size. We have 0.25 times the complement over the sample size. Yeah, so B-boy is good to go. So what was wrong with D? Oh, wait, that's wrong. So what was wrong with D-dog? D-dog had the wrong decimals. 269 and 731. I'm not real sure where they got those decimals from. So anywho, wrong decimals. So B-boy has it all right. Okay, what is next? Let's see, 21 and 22, huh? You didn't like those last two problems. Okay, so we have a 90% confidence interval. That's taking a difference between these two. Ah, okay, interesting. So this is saying that 0 is captured, right? 0 is in this interval. 0 means there's no difference. All right, when you think about the hypotheses for this section, we would say the difference between them is 0, meaning no difference. And then the alternative is, hey, there's something going on. There's a difference here. All right, but because 0 is a potential true value, it's been captured in our net of truth, we can't reject the null hypothesis, right? The idea that there is no difference between these groups has to stick around. So, since the confidence interval includes 0, the researcher cannot conclude that the proportion of iPod owners is different. All right, we cannot conclude different versus no difference. All right, so that's how the net and the magnifying glass overlap. All right, so if 0 is captured, that means the null hypothesis cannot be rejected. We don't have the evidence. And last but not least, how much more effective is exercise and drug treatment than drug treatment alone? To find out, they did a randomized experiment. Half received the drug, half assigned the exercise and the drug. The most appropriate inference method for answering the original research question. All right, so the original research question wanted to know how much. Right, we want to know what the truth is. What is that value, right? What is the true value. In order to find how much, we would have to pick up our nets, right, to try and capture the truth. So since we have two groups, we're definitely doing twos. We can get rid of one SAMP. You haven't learned about T's. Those are for averages, right? Means. And this particular problem isn't a mean. This is whether or not they had success, right? Ah, there you go. Whether or not they had heart attacks. Yikes. All right. So then it's between an interval and a test. Again, since we're trying to capture a true value, that's going to be an interval. All right. When they're asking how much, that's an interval. Example of keywords for a test, they would ask for evidence. So if this was a little bit different, if they said, is there evidence that exercise and drug treatment are better? That's when it's a test. But if they want an actual value, how much, that's going to be an interval. All right, so that's it. Those are all the ones that were starred. Let me take one last look just to make sure. If there was a particular problem that I didn't go over that you want to see, feel free to hit me up on the Zoom chat today and I will happily do one of these for you. I'll see you around. Miss ya.